Right. Okay, so we're going to have a look at something called standard form. Now, standard form is really just another way of writing numbers. And we use it, it's particularly useful, standard form, for when we're writing either very small numbers, and so that might be if we're talking about the size of an atom. You know, if we were saying how many millimeters across an atom was, it would be sort of 0.00000000000000001 of a millimeter or something like that. It's going to be really, really tiny. That's a very hard number to keep writing out. So using something called standard form, we can write them in an easy, standard way, which just makes them a bit neater. But the bit we're going to look at today is for large numbers, and this comes up again in science, I suppose, when we're talking about really big numbers like how many stars there may be in our galaxy or in the universe, maybe, or whatever. Huge numbers. And writing that, you know, these massive numbers out it's really time consuming, and it's much easier to work in something called standard form, which keeps it very neat and compact. Now, standard form has two parts. Now, you should be writing notes, clear notes that you can work from, just like if we were actually in the classroom at the moment. So make sure you're copying this down, ideally, you know, using a few colours as well. Right. So this is a standard form number, right? 2.45 times 10 to the power of 5. So the first part is a single digit, so there's one digit, possibly followed by a decimal point. But there's never ever two digits before the decimal point. And it also can't be a 0. There must be a proper number before... Oops. That's all gone a bit wrong, isn't it? There must be a proper number before that decimal point, if there is one. Just one single digit, and it can't be 0. All right? The other part is this power of 10. And the power of 10 kind of adjusts it. It tells me that my number isn't really 2.45. It's actually those digits, but, you know, times by 10 5 times. Actually 5 places bigger. So it works like this. So let's start with 2.45 equals 2.45, right? This is just a demonstration. Don't feel you need to recreate this, right? This is just me showing you how it works. So we've got 2.45 equals 2.45. Now let's times both sides of this by 10, right? If I'm timesing both sides by 10, they'll still be equal. Now one side will times by 10, and the other side will actually say what the answer is. So if I times the left-hand side by 10, I get 24.5. All right, these things are still equal, okay? Let's do it again. Now if I times it by 10 again, on the left-hand side I've just said, like I'm timesing it by 10 twice. On the right-hand side I've timesed it by 10 twice, and I've got 245. These things are still equal. But look, this bit here, the times 10 times 10, well, we can neaten that up, actually, can't we? We can use our powers here, because when something's times by itself, there's two of them, so we actually put to the power of 2. And this means basically times it by 10 twice, and you get 245. Let's do it again. Now, if I times it by 10 again, my power is going to be 1 bigger, because I'm timesing it by 10 again, and the right-hand side is now also times by 10. It's now 2,450. And I'll do it again. My power gets bigger by 1 number again, and the right hand side has also been times by 10, now 4 times, 24,500. And then if I do it one more time, I get 2.45 times 10 to the power of 5. I've timesed it by 10 5 times, and on the right hand side I've written that out, and it's now 245,000. So this standard form number here is really 245,000. It's just a much neater way of writing it. You know, and we could go further. We could write massive numbers, but they'd still look no bigger, really, than this thing I've circled in blue, which is my standard form number. So if you haven't made any notes yet, pause the video and make some notes, particularly this bit here that shows you what standard form is with the single digit and the power of 10. Okay, so this is the bit you need to nail. This is the bit where we're going to write numbers in standard form. Okay, so I'm going to give you some numbers, show you how to write them in standard form, and then you can practice as well. Right, remember, the first bit is a single digit. Now, actually, on here, we've only got a single digit, so that's okay. So I'm just going to write down that bit, 7. Now, I'm going to times it by a power of 10. Now, all I need to think is, how many places bigger is my real number? Now 7, how many times do I need to times it by 10 to turn it into 7,000? Well, I like to think about where the decimal point would be. Now the decimal point on 7,000, it looks like there isn't one, but there's always a decimal point, and it's always tucked off just to the right there. And I like to think, if the decimal point was moving, now we know the decimal point doesn't really move, right? So we're just pretending here. Really, our numbers shift, don't they? But if it was moving, it would go 1, 2, 3 jumps to turn it into just being 7. So my number's actually 3 times bigger. So it's 7 times 10 to the power of 3. It's really 3 places bigger. Don't be fooled though. I know some people are thinking, well, it's 3 zeros, 3. Although some of them will work like that, they don't always work like that. So get used to moving that point if you need to. Right, for some reason that comma's in the wrong place, but it doesn't matter. That's 50,000. Okay, so what's my digital bit? What decimal bit? What's the digit? The digit is 5 times by 10. Now, it's not really 5, is it? It's 50,000. So how far would I have to shift it? 1, 2, 3, 4 places to get that decimal point behind the 5. So it's 5 times 10 to the power of 4. So work out the decimal bit and then work out the power of 10, how far it's gone. Here, so my digit there is 6. So just write 6, okay? Don't even need to get it, do we? It doesn't matter if you don't get it because, well, nothing to get. Just literally write the number down. And then put 10 to the power of, how many places has it moved, right? It's moved 1, 2, 3, 4, 5, 6 places. So 6 times 10 to the power of 6. My number is not really 6. It's 6 and 6 places bigger. 6 million, that number is. Okay, try it for yourself. There's 3 numbers for you. Write them in standard form. Pause the video. Unpause when you're done. Right, the first one, 3 would be the digit. And the power of 10 is it's shifted 1, 2, 3, 4 places bigger. So 3 times 10 to the power of 4. Now this one, 2 is my digit. 2 times 10 to the power of 1, 2, 3 to get that decimal point just behind the 2. So it's really 3 places bigger. And what about my 7 here? Let's see, 1, 2, 3, 4, 5, 6 places bigger. So 10 to the power of 6. It's really 7 million. Right? All these numbers in red on the side are of standard form. Cool, okay. But sometimes we need a decimal point. So this one, I can't write 45 times 10 to the whatever it is. Because remember when we said standard form, it can only have one digit in front of a decimal point. So I'm going to put my point in there. In some ways, these are a bit easier. Now I've just got to get how far has my point got to move to get it so it's tucked behind that 4. 1, 2, 3, 4. 4 places bigger, so 4.5 times 10 to the power of 4. Standard form. Okay, same digits, right? Just write those same digits you've got there, but with the decimal point after the first one. So 3.06 times 10 to the power of 1, 2, 3, 4, 5, 6 places bigger to get that point behind the 3. So it's times 10 to the power of 6. 3.06 times 10 to the power of 6. Last one. Okay, here's my digits. 712. Remember, we need to tuck that decimal point just behind the first digit, so 7.12. And then times it by 10 to a power. How far has it moved? 1, 2, 3, 4, 5, 6 places we've gone. Look, I'm bouncing it. If you can't see, I'm bouncing it into the gaps in between the numbers each time, because that's where decimal points live. So that is 6 places bigger. 7.12 times 10 to the power of 6. Okay, your turn to have a go at some of those. Pause the video, have a go. Make sure you write the question and the answer, and do corrections if you need to. Unpause when you're done. Right, okay, so you should have 3.8 as the decimal part, times by 10 to the power of 1, 2, 3, 4, 5. 10 to the power of 5. This one, 406, so 4.06. Always have that decimal point after the first proper digit. Times 10 to the power of 1, 2, 3, 4, 5 places bigger again. So 4.06 times 10 to the power of 5. And there's my digits. And so it's 9.24 times by 10 to the power of 1, 2, 3, 4, 5, 6 places bigger. So 9.24 times 10 to the power of 6. Now, if you didn't get that, maybe just have another go at it or just maybe rewatch that. But make sure you've got some examples and some notes. Right, first one, 5 times by 10 to the power of... Well, actually, why am I doing that for you? It's your turn. Pause, have a go at those 8, and then unpause when you are done. Okay, unpaused. You should have. Okay, I hope we're getting a bit quicker at this now. 5 times 10, 1, 2, 3 places. 5 times 10 to the power of 3. What about this one? 6 times 10 to the power of 1, 2, 3, 4. 6 times 10 to the power of 4. This one, right, 9.5 times by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8. Oh, makes your eyes go a bit squiffy. So 9.5 times 10 to the power of 8. This one should be 3.46 times by 10 to the power of 1, 2, 3, 4. 10 to the power of 4. All these numbers are exactly the same, really. It's just we're writing them in a different format, but they're still the same numbers. Sometimes it's handy to have little 1,000 separators. Every 3 digits you have a little separator, a little comma. But 6.72 is the decimal part, times by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Times 10 to the power of 10. F, 6.5 times by 10 to the power of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 again. 6.5 times 10 to the power of 10. This one should be 8.46 because those are my 3 digits. Times by 10 to the power of 1, 2, 3, 4, 5. Okay. And lastly, there's my digits. Put a decimal point after the first one. So 5.78 times by 10 to the power of 1, 2, 3, 4, 5, 6, 7. Tricky when there's no little comma separators, isn't it? But I hope you had a good go at those. Now, of course, the other skill we need to be able to do is to be able to write standard form numbers as normal numbers. So, for example, this one. Now, 8 times 10 to the power of 4. So it starts off life as 8, but now it needs to be 4 places bigger. So that's 1 place bigger, 2 places, 3 places, 4 places. It's really 80,000. Now, particularly when there's no decimal there, it makes it a bit easier. But what about when we do have a decimal? Let's see. Now, this needs to be... It's like 1.2, but 3 places bigger. Now, the first thing to do is actually go 12. Now, that's 1 place bigger, isn't it? 1.2 becomes 12. That's 1 place bigger. And then 2 places, 3 places bigger. 1,200. Okay, get the idea? So 5.6 needs to be 5 places bigger. So the first thing to do is turn it into 56. So that's 1 place bigger. But I've got another 4 to go because there's 5 in total. So 1 to make it 56. And then that's 2 places, 3 places, 4 places, 5 places. Yep. Don't just put 5 zeros on the end because we need to use up one of those places, getting that decimal point past the 6, don't we? Past the 6 and then 4 more jumps. Okay, have a go yourself. There's 3 numbers for you to do. Pause the video. Remember, write the question and the answer. The question and the answer. And then unpause when you're done. So this one, it's 7, but 5 places bigger. 3, 4, 5 places bigger. It's 700,000, really. 6.4. So, firstly, 1 place bigger is 64. That's, the points moved over that 4, or the fulls moved. So that's 1, and then 5 more. 1, 2, 3, 4, 5. Okay, that's 6,400,000. And 8.1 times 10 to the 4. Well, first of all, let's write 81. That's 1 place bigger. And I've got a total of 4 to go. So that's 1 place, 2 places, 3 places, 4 places. Yeah. Again, don't just put 4 zeros on the end. It needs to be 4 places bigger. If you're really stuck, you could think about doing this thing we did last time, didn't we? 8.1 becomes 81, which becomes 810, which becomes 8,100, which becomes 81,000. You could write it out like that if you want to. It takes a bit of time, but you know that you're definitely going 1 place bigger each time. Okay, 3 more for me to show you. What about if we've got a couple of decimal places? Well, okay, this time it's 4.62 times 10 to the power of 3. So 3 places bigger. So first of all, 2 jumps turns this into 462. So that's 2 of them, but I need 3 in total, so that's 1 more place. So 4,620. Make sure that you've shifted your number and got past that decimal point first. Oh, turned it into a whole number first. So 1.07. So 2 jumps turns it into 107. And I need 2 more. I need 5 in total. I've used 2. So 3 more, isn't it? 3 more there. 107,000. And 3.101 times 10 to the power of 6. You know this now. So first of all, 3,101. That's 1, 2, 3 places bigger. But I need a total of 6. So that's another 3 places bigger. 3,101,000. Okay, I hope you're finding this not too bad. If you are, maybe you should, feel free to watch it again. But pause the video, do these 3 questions and answers, please. Unpause when you're done. Right, you should have 516. That's 2 places bigger. And then 2 more to get us up to the 4. 51,600. Right, 701. That's 2 places. And I need another 4 places bigger. So that's 7,010,000. Well, this one, loads of decimal places. 5203. 5,203. That's 1, 2, 3 places bigger. But I need 5. So that's 2 more places, isn't it? 520,300. Right, time to practice this. This is the best way to do it. Practice these ones. Write them out as normal numbers, please. G might take you a bit of time. And unpause when you're done. Questions and answers, don't forget. So A should be 4. And there's going to be 7 zeros after that one. That one does just need the zeros added. So 40 million. Let's go for B. So 3.6. So 3, 6, that's 1 place, and then another 8. 1, 2, 3, 4, 5, 6, 7, 8. That is a really big number. That's 3,600,000,000. See, it's a really neat way of writing these numbers, isn't it? These really big numbers. Much neater as standard form. Right, C. 53 first of all. That's 2 places and another 3 places to get 53,000. D, will I have enough space for this number? Let's see. Right, 6, 2, 4. That's 2 places bigger. I need another 6. So 1, 2, 3, 4, 5, 6 to make a total of 8 places bigger. 624 million. That's nearly as much as I earn every week. Right, 3.45 times 10 to the power of 7. 345. That's 2 places bigger. And another 5. So you should have 34,500,000. F 2.6 to 10 to times 10 to the power of 4. Well, 26 is one place bigger, and another 3, so 26,000. Oh, that's a rather neat little number, isn't it? G, right, 5, 2, 6, 4. So 5,264. That's 3 places bigger. 1, 2, 3. But I need 13. That's another 10. Crikey. 3, 6, 7, 8, 9, 10. Blimey. I'm not even sure what that number is. What is that? That's millions. That's billions. So 52 trillion, 640 billion. That's massive. And this last one, 8754. That's 3 places bigger, but we need a total of 6 places, so we put another 3 zeros. 8,754,000. Okay, apologise about the bad writing there. It's a bit tricky on the screen. But okay, off to Dr. Frost for you. Now you should aim to get all these questions right. If you get any wrong, you need to redo them until you've got everything right. Okay, make sure at the end of this lesson you've got clear notes, clear examples, you've done all your marking, and you've had a go at these questions and got them all correct, okay? Obviously, if you run out of time, you run out of time, but don't finish early if you haven't, all right? Well done, and I'll see you next time. Bye-bye.